Thank you for joining, especially being the last session of the day. We are going to be going over maximizing cloud performance and availability. And that conjunction is very important because it plays very much into what we'll be talking about today. In terms of who's up here, I'm here with my colleague, Denzel. Denzel gave me permission to just point to him for now, but he'll be showing a lot of really intricate demos today. And by the way, Denzel is a program manager on the Azure SQL Database team, along with me. His focus area is on hyperscale, and I'm on the query processing team and within Azure SQL Database. And the work that we do goes both into cloud and into the SQL Server product. So with that said, overall objectives, we are going to go over three main areas, but they're really woven in. So while this is separated out, it's not necessarily isolated and sequential. First thing is we want to make sure you hear about intelligent database, you hear about intelligent cloud, and there are a lot of things that you can do to just move into the cloud, allocate a database, and just set it and forget it. So there is a level of automation and abstraction where a lot of customers don't have to think about performance or availability to that much of an extent. However, there are optimal choices that you can make proactively to increase the odds that you do not have to worry about it. So we will be talking about some of those factors that are important for ensuring success when you move to Azure SQL. We'll also be talking about how many folks are SQL Server performance tuning experts, or at least you feel comfortable performance tuning. Okay, all right, great. So a lot of hands. You are about an inch away from Azure SQL level performance tuning skills. So it's really not that much of a gap. So a lot of what we'll go over today is what is that critical, a little bit of distance that you need to go to be Azure SQL data ready with your performance skills. So we'll go over that. And then the last aspect is around real-world patterns. And part of that is a hybrid of what Denzel and I have seen, what our team has seen. If you have a performance issue in Azure SQL Database, and let's say you can't figure it out, and we're going to give you lots of tips today on how to figure it out. You can't figure it out, you open up a case with CSS. I have a case with CSS, they're doing root cause analysis, and let's say they can't get to the bottom of it. What they will do is they can escalate to the engineering team. So we actually have a DevOps model, and so engineers for query processing, for hyperscale, for elastic pools, all the different engineers in Azure Data are on call. They're on call rotations. They get called for both internal and external customers. The program managers, of which both Denzel and I are, we have a front row seat to the types of patterns when these, what we call ICMs, or these incidents, are opened. And so we picked a lot of the themes based on that front row seat, again, so that you could learn from some of the patterns and figure out how to, first of all, diagnose it, and then also mitigation and overall proactive handling of it. All right. So with that said, I'm going to start off with some first principles because we are changing all the time. How many folks have worked with SQL Server back in the 2000 to 2005 days? Okay. So do you remember those days when you could look up a fact and it would remain a fact for like a year or even 4 years? So you go, yes, this is the way it works, and I don't have to double check it. Well, that's not the world anymore that we live in. Azure Data, we're always adding new things, we're always changing things, and that's not just actually us, our competitors as well. It's an ever-changing set of portals, features, APIs, scripts. And so I want to at least establish first principles as they stand today. And lay out overall, when we talk about Azure SQL and the performance tuning and availability story, what are we talking about? To do that, I'm going to start basic, but don't worry, Denzel is here and he can go very deep very quickly. And so again, this is just laying so that we're speaking the same language about Azure SQL. So the first thing is, why are customers coming? I think that when we saw the keynote, I believe Rohan quoted the 5 million database number. So we have customers using the service. And one of the factors that we see over and over again is it's a very familiar ecosystem. So SQL Server has, as evidenced by this conference, a huge amount of mind share, a lot of talent, a lot of people that are comfortable in the space, a lot of developers that are comfortable in the space. So we see this natural migration where I don't want to have to learn something new. I want to use something I'm familiar with, but I want the platform as a service benefits that are associated with it. And so what are those benefits? First and foremost, it's the ability to scale up and down quickly. You are not punished if you make a misestimation about, let's say you're preparing for Black Friday, you're a retailer. You need to make sure that you properly estimate the hardware that's going to be needed a few months from now. In Azure SQL DB, that's an hour-long decision. Maybe you go, oh, I under-provisioned or I over-provisioned. You resize, that next hour you get billed at a different rate. If you were in the SQL Server world, you're provisioning, you might actually be stuck with something that's way more than you needed, or even worse, it might not be enough to absorb your traffic. So a lot of customers are coming to this because of that ability to scale up and down. Automatic backups. I don't know about you, I love performance tuning, but to me this is not the most interesting subject on earth. And so the fact that we take care of backups, that we have the full backups, the differentials, the transaction log backups, that we're doing that automatically the minute that you provision it, is another big benefit that people look towards and begin to actually take for granted in a platform as a service. The ease of HADR. So setting up an availability group topology. I mean, if I look across the room, I already see a few faces that I know they could actually do that in their sleep. They can set up an AG topology, they can set up a failover cluster instance, they can do log shipping, they can use transactional replication, merge replication, peer-to-peer. There's a lot of that talent in the room, but with many of our customers, this is not something that they want to be in the business of doing. They want to provision it and they want to go, okay, just meet the SLA, just please actually just handle that for us. We want to know exactly what SLA you're honoring, but I don't want to worry about setting up that topology. Security, another big subject, another thing by default. You provision a new database today, it's going to have TDE on by default. You're going to have things like automatic threat detection, which is ever evolving. We're always adding new rules about that. You're getting very sophisticated cloud scale type security, and it's a click away to be able to enable. Latest code base. So as of SQL Server 2019 GA, we already had this in cloud. All right, so you have compatibility level 150. You are able to leverage a lot of the new QP pieces of functionality. You have the ability to use new keywords. We will flow that in over time. And it's just there. You don't have to worry about the 3-year hardware refresh to start leveraging that new functionality. And then automatic patching and upgrades. Similarly, you're out of the business of CUs and service packs and so forth. So that's the big drive towards why we're seeing a lot of this adoption. Let me talk now about deployment models. And again, I'm bringing this up as just making sure we go at this point of time, this is what we have. And we offer a lot, and some of the feedback that we sometimes hear is there's too much, or there's so much that we have to keep learning. And so this is a way to bring a little cohesion at this moment in time. So when Azure SQL Database was first introduced, you had the concept of a single database, and that was your unit of deployment. You paid for the resources that were allocated to that database, so we still have that today. You also have the concept of elastic pools. So if you have, let's say, 100 different databases of which you might have unpredictable usage over time, and you want to just pay for that pool and allow that elasticity of workload to go on within the constraints of that pool, that's an option that we found has been very popular with ISVs, with software vendors that might have multiple tenants. And then similarly, we have managed instance. So, and I'd say recently, but they've been doing so much over the last 1.5 to 2 years. And this is really for that lift and shift scenario. So where you don't want to change much, or you cannot change much, and you want to have that near compatibility experience where you have the instance and you have the databases. So we've offered that. And then hot off the press is the concept of managed instance pools. And this actually allows you to say, okay, I want to pay for this pool and have one or more instances within it, which includes even things down to like 2 vCPUs, which is the way to do it only through instance pools. So if you want small instance sizes. So that's deployment options. Now, you also have different purchasing options. So we have the classic DTU model, which was introduced initially out of the gate. And that was the whole concept of, don't tell me about the underlying resources. I don't want that level of complexity. Just give me the equivalent of a horsepower. Like I want X horsepower to drive this particular engine. And in terms of our offerings, you see we have basic, standard, premium, and the whole idea is depending on how much you need, you pick that associated tier. Now, this abstraction works with some customers. With some customers, though, they said, look, I don't know, I still, even with calculators or with the guidance from consultants, I'm still not clear what should I be using. I have something that's an 8-core scenario today with X amount of memory and this kind of I/O path, where should I move? And so we also introduced a vCore purchasing model. And similarly, we offer different flavors of it. So you have general purpose, you have business critical as they're named. Actually, I saw a pre-con, so my colleague Jovan sitting up here, he actually mentioned, when you're thinking of moving over, keep it simple. Start with general purpose. It might actually be okay. And then if you need to have enterprise or business critical type workload patterns, you can always move into that offering. And of course, from a PM perspective for Denzel, we have hyperscale, the ability to take OLTP and hybrid workloads and run against a database up to 100 terabytes in size. All right, now this was not meant to be read from stage. This is more of a reference slide, but I just wanted to point out, if you're interested in how we break out the dimensions, so we move from DTU model, where it's this abstracted horsepower, to, all right, here's everything, all right? And so I would say, just note vCore service tiers, when we upload it, we'll have the links, but this is a very rich set of resources to tell you, okay, what do you get when you go from offering to offering? And so be aware of that as you start to think through what you're going to do and how you're going to first land in Azure if you're first landing, or if you want to move around with an existing implementation in Azure SQL Database. Okay. In terms of benchmarking, we've been pretty quiet over the last few years. And part of the problem is the TPC benchmarks are not necessarily cloud-focused. So there's some modifications that need to be made about it. But we're going to start speaking up a little bit more. We're going to work with different partners to get the word out so you can start having reference points for how we perform. And one of the areas that we have a lot of traction on, we have lots of different industries in the service today. But one industry that we have that deals with performance in particular, and especially cognizant of price performance, is gaming. So we have a lot of gaming workloads. And they're very interested in scenarios where I'm about to launch and I need to provision X number of databases and I need it to perform as much as possible. And then after launch, I need to ramp it down. And so they need to be cost effective, but they don't want to sacrifice performance. So in this particular study, and I'll just speak to it at the broad strokes, we were comparing an RDS database, an R4 equivalent to a BC Gen 580, so a Generation 5 business critical 80 vCore. None of this perfectly matched, by the way. So this is the other thing. If you try to do apples to apples between RDS and our offerings, you're going to find everything's off a little bit. We have lots of different intermediate options. We might have more cores. They have more memory in one particular offering. We have elastic. We have single. They might say, well, go to Aurora versus SQL. So you're going to find there's going to be this back and forth. And this is actually good ultimately for the customer because it keeps us both on point, and we're going to keep trying to compare and get more and more of this information out there so you can be better informed. But as of this particular study, the key thing I want to just point out here is if you have licensing on-prem, you can actually convert that over through an Azure hybrid benefit and get significant savings on top of the existing offerings in Azure SQL Database today. So in this one point, you see up to 86% savings if you're doing a reserved instance as well. Okay. And another layer, and now we're almost past the basics. SLAs and availability and your whole business continuity, disaster recovery story. We have had existing SLAs, and we most recently added BCDR SLAs around recovery point objective and recovery time objective. And why is this woven into the overall talk about performance? When you go out and provision a database, out of the gate, we're going to have that in mind. We want to honor that SLA. We want to make sure that we keep your database up. We want to make sure that we don't lose data. And so anyone can go ahead and provision a database somewhere, put it in simple mode, not set up any kind of redundancy, not have it in an availability group, no replication, nothing like that, and get extreme performance. But we want the experience to include the full picture by default. So this is just a reference for you. There's a full link here to go through our overall SLA. As of the time of this writing, I believe as of right now, again, like I'm jittery about any kind of guarantees unless I check every single day, but as of the time of the writing just a few weeks ago, we were the only ones to have this BCDR, or business continuity type SLA. All right, let's get into a little bit of performance tuning discussion. I'll do a few more slides and then Denzel will resume from there. First thing is, how many folks are not in cloud today? I'm just curious about, okay, a few hands. And then how many folks are in Azure SQL Database specifically? Okay. So as folks have moved over to Azure SQL Database, we found that there's specific themes that repeat over time, and especially the anti-pattern themes. So we'll talk about a few of these. First of all, when you're trying to size, if you're doing the DTU model, that's, there's calculators, there's general guidance. But if you're thinking of the vCore model, a general rule of thumb is how many CPUs do you use today, how much memory, and trying to at least just start with a rough equivalent. And quoting Jovan on this, keeping it simple, maybe pick the least costly first, because that oftentimes might be okay. And we're seeing that's certainly the case with Azure SQL Database customers. The other thing is there's a lot of side notes about how to save money here, like having you scale down. And you're probably thinking, well, why are you telling us to scale down? The idea is more and more consumption. But it's no good to us if you over-provision, it costs too much, and then you leave. So the idea is we want customers to be right-sized as much as possible. Okay, so we already talked about you can scale up and down accordingly. I will say this, and this will apply to many different sessions that you've probably already seen, and then you'll see tomorrow as well. When you have the opportunity, please test your performance ahead of time. So we have mission-critical big companies that might have a department, and that department might have provisioned their own database. And that database might be the back end for an extremely critical service that's the lifeblood of their business. And they push it out there, and we've had scenarios or escalations where they go, well, nobody tested it, the DBA team wasn't even aware that this was going out there, and now we've got crisis. And so just as part of this overall runbook, whenever you can, try to test ahead of time with representative workloads, with representative data distributions. I'm not doing wavy hands here because it's very effortful to get an actual workload that's not contrived. And yet it's worth that investment, especially if it is your business critical application. And then the other thing is compatibility level. I mentioned a little bit earlier, so we're evergreen code base. So you have a compatibility level 150 in the service now today. But it's not the default yet. We'll start rolling out as a default now that 2019 has GA'd. But the key thing here is we do not force you upward. So if you are on compatibility level 110, we don't bump you up just because 150 is there. We keep that there. You might have a new default, and you are very welcome to then go ahead and downgrade the default to whatever compatibility level you have certified your own applications on. So just be aware, we will support you. We want this to be as friction-free as possible. And then the other thing, and I'll mention this because of the SQL Server talent in the room, we know at PASS, a lot of folks are performance tuners, that just as you would do with a SQL Server machine, let's say you provision a machine with 8 CPUs and a finite amount of memory and a finite I/O path, just like that, you have to use a performance tuning methodology when you're encountering an issue where something might be slow or not as fast as you want it to be. And we mentioned the methodology because you can always go on a fishing expedition. So I can always go in and I can find a missing index. I can find a blocking process. But are you actually troubleshooting the correct thing? And that's what we'll talk a little bit about today. All right. So in terms of performance tuning in the cloud, a few factors. What are some things out of the gate that are a little bit different than the SQL Server world? First thing is that I mentioned the availability. You're balancing performance with availability. We are running in full recovery model. If you're in something like business critical, you have up to 4 different replicas behind the scenes. So that is just a fact once you deploy. The other thing is that there are necessary limits, and those limits are calibrated for the SLAs that we've defined. And you'll see 2 different links here as references afterwards. Now, I have a performance issue. Somebody calls me up at 2 a.m. in the morning, and they say, okay, something's running slowly, and you're in Azure SQL Database. Very similar to your SQL Server experience. Where do you start, though? Okay, so if you don't want to use dynamic management views, you can go to the portal. You can see the utilization by data I/O, log I/O, CPU, right front and center. If you like dynamic management views, you can use them. So there's this sys.dmdb resource stats. You're going to see this in a few different demos. And you check the resource consumption, because if anything is running hot, if anything is running in the 80s to up to 100, or it's flatline, totally pegged out, that's the beginning of the discussion. You want to troubleshoot based on that. If I'm saturated on CPU but not I/O, that's a different discussion than an I/O discussion. So speaking of CPU, next, after we check the resource utilization, then you'll check, okay, am I running CPU hot? And if I am, if it is a high CPU scenario, let's say 90% consistently over time, is it execution or compilation overhead? And for this is all the classical SQL Server techniques that you could use: query store, dynamic management views. You can see both history and current running requests, sys.dm exec requests, sys.dm exec query stats. And by the way, the query store experience, again, in cloud, it's turned on by default. So unless you turned it off, this will be there for some basic telemetry that you can then go through and say, oh, okay, who are the big consumers? Now, if I was not actually running hot on CPU and it was just running slowly and it wasn't clear, it wasn't compilation, it wasn't execution, then we look at weight statistics. So similar to the old school weights and queues methodology that you've probably read about in papers, or the different DMVs you might have explored, you would look at what's waiting. And that, again, is the classic set of tools. So sys.dmos weight stats, sys.dmdb weight stats. Looking at query store. So back in the 2017 timeframe, you have classifications of different resource weights that get captured in query store associated with your plan stats. So you can actually see, okay, for this particular plan, we have a lot of wait time that's related to memory grant overhead. So in terms of just the overall set of weight categories, again, this is all the same. So really the only part is this, what I'm circling right here, is that checking that resource consumption, and then the rest flows as you normally would in the box world. Okay, with that, I'll switch over. There you go. Yeah, oh, just, yep, right there, good. Oh, and go back one, yep.
Help if I'm turned on. So from a tools perspective, I'm not going to spend a whole lot of time on some of these tools because they're familiar. Query store we all know, DMVs and extended events. The ones which are a little different are Azure SQL Log Analytics, which is an optional thing. So that's not out of the box kind of free. You have to provision your workspace, and you can have insights and choose what type of data flows into SQL Analytics. Then you have the database advisor and the automatic tuning set of options. Joe will show you some slides towards the end in that realm. And then we have some other monitoring options, including third-party tools. Jovan has a query performance insight library, which is a set of scripts which makes it easy to troubleshoot issues. And there are some other open source tools, such as the Telegraph, which is plumbed for Azure SQL Database as well. And I'll be demoing some of that in my demos so that we can see real-time performance. OK, so let's switch to a demo now. 3? I'm 3, right? Yep. 4. No, 4. I'm 3. OK, so the first one we'll look at is data loading in Azure SQL DB. So Joe did talk about resource stats quite a bit, so I'm going to show you what that looks like just for a second, because some of these dashboards are based on these. So you have CPU, I/O, log, and these are percentage of the cap, which is the limit of your tier that you have chosen. Another very interesting DMV, rather than going through documentation of what the limits are, is this DM user DB resource governance. So running this query, I've just pulled out a couple fields which are relevant. It gives you the slow, it gives you the service level objective, it gives you the CPU limit, the memory, the max DB size. This is the primary max log generation rate, so on and so forth. So some of that table that he was depicting, those values are in DM user DB resource governance. So I'm going to create a table and start with the bulk load scenario. So creating a table, And in order to bulk insert into Azure DB, I have to do some infrastructure in terms of creating a master key and giving it the SAS token to my storage account where my files reside. So I create a master key, and I point it to my storage account, which has the files in question. And then I create an external data source that points to the set of files that I'm going to import or use in my bulk insert demo. Having said that, so I'm going to bulk insert into a table. Note some things. Batch size is 100,000, and I'm using tab locks so that I can get the best performance and have multiple streams later on. So I start this bulk insert, and we're going to switch to a dashboard, which is that Grafana-based solution or telegraph that monitors SQL DB. I switched to the demo GP, and a couple things stand out. So this is an 8-core tier for SQL DB, general purpose. The max log rate is 30 MB, and you have a couple other IOPS limits, right? These are all pulled from the resource governance DMV. If we give it, let me switch to 5 seconds. Pretty soon you're going to see that this log write percent is climbing quite a bit. It's almost 70% in this chart. And this is pulled from the resource stats DMV. And the rest of the counters are either pulled from the wait stats or perfmon. So perfmon doesn't exist. Perfmon exists on Windows, right? But there is the DMV for DMOS performance counters, which this pulls and actually charts out to give you kind of some visuals of that. But you can query it with any tool. So since this is a load, what I wanted to show you is log bytes flushed per second. I'll zoom into this portion. And you see, we've not even hit the max cap, so we are below the 30 Mbps rate. Right? So this is a single thread bulk inserting values. We have not hit any wait types. Well, we hit some wait type. It's called improv IO. And this is a wait type you see, so I want to address it. This is a wait type that is used when you're reading the bulk insert file. It's nothing to do with actually inserting to SQL. If you want to get rid of this wait type, you can use a compute engine like Spark or ADF, or just offload the bulk insert portion so that SQL Server is not reading the file, and then stream it with SQL bulk copy to SQL. Right? So that's one aspect. So I didn't hit the log generation rate, so of course I can go parallel on this, and that's the way you actually get higher load throughput. So I'm going to switch to this PowerShell script. And this PowerShell script actually will load 4 processes. So you have 4 parallel processes into the same table. So it's the same table, same schema. Nothing is really different other than there are 4 of them. And so I start 4 bulk loads, and then I'm going to look at some diagnostics. I've simplified queries and just made stored procedures to get the requests. This is looking at sys.dm exec requests primarily. I see 4 bulk insert statements as expected. They're my parallel bulk loads. And pretty soon in a bit, I'm going to execute it again to show you that. Am I on demo GP? Not yet. OK, improv IO wait. So it's reading the file right now. And in a second, we should see wait types that show that we've hit our log generation limit. So this is the first wait type that actually is not on box, right? So you have log rate governor, which indicates that I've hit my 30 Mbps limit for my tier. And so now I'm going to get throttled in log generation rate. So this could be a bulk insert. It could be other inserts also, anything that generates log effectively. So you've hit that tier. So let's go and see the dashboard because it'll make it easier to see. Last 5 minutes. So I have 30 Mbps. We see this is what you would see in Portal. It just is this is a bit quicker in getting that data. So it's flatlined at 100% of cap. So that should be 30 Mbps. If you look at our weights, you see the log rate governor right there. I'll just zoom into this last part so it makes it a little easier to see. Log rate governor. And if you look at log bytes flush per second, we are at the 30 Mbps mark. somewhere there. If I had to zoom out a little bit, probably you would see the progression. Yeah, we are capped at around 30 Mbps. So we've hit the weight, and so now what's your solution? If you want to stay with the same tier, you've got to go up a level to the next tier in order to alleviate your bottleneck. So this is, and there's difference in tiers too. So as we talk about deployment models, you have general purpose, you have business critical, and you have hyperscale. So I'm going to switch this demo to look at hyperscale. So same demo, one fundamental difference. I'm going to go and take 8 streams instead of 4, right? And I just go to a hyperscale database. This took, timing-wise, this took 1 minute, 1 minute and 9 seconds. Sorry, 1 minute and 9 seconds for those, 4 streams. So I'm going to execute the hyperscale one. And so I have 8 streams going on now, right? If I want to look at the requests, I can. Double check. Yes, I have 8 streams. But I won't see any, I shouldn't see any wait type, because the tier for hyperscale gives you higher log generation rate irrespective of cores. So I'm going to switch my database. You'll see even with 8 cores, I have a max log rate of 105 Mbps, right? So 100 Mbps is the log generation rate. And my log write percent is not at 100 yet. And I don't have any, I have the improv IO still because I'm bulk inserting, so reading the files is still the same, but I don't have any log rate governor or any weights here. And from a log bytes flushed per second, I have gone up to probably the 80 MB per second. So that's how tiers do matter, and some of the weights are a little different when we have resource governance based on the tier limits. Okay, so that's demo number 1. So I am just going to actually show from console. So for log rate governance, there are a couple weights. One is log rate governor, but you also have a few others when you have HADR replicas which are behind. If a geo-replica does fall behind a lot, I mean, your primary log generation rate can be throttled. So these are all documented in the link there. So you can take a look. So it's not only log rate governor. There are a couple others associated with them. And then hyperscale has a different set of weights for hyperscale. I'm doing a session tomorrow if you're interested in some of the diagnostics specific to hyperscale, which are slightly different. Yep. Yes, you can put an alert. Yes, the question is, can you get an alert when that happens? Yes, you can have an alert on the resource stat reaching 100%, right? So it can send you an email. If it persists for X number of minutes, you can choose the alert frequency, yes. Yes, you can. So other data loading tips are kind of similar in a way. So you have SQL DB is in full recovery model. So please don't baseline against simple recovery model, because that's not what SQL DB is on. The tab lock, and if you're using column store, use a batch size that lands in compressed row groups. You'll get better performance that way. Use column store for tables which are large and you're doing aggregate type queries anyways for 2 reasons, right? So you'll get better performance on reads. But also, if it lands on a compressed row group, it generates less log as you land the log. So, your log generation rate matters less, if you will. Partitioning is very, very important, and it's probably one of our less used features. So on large tables in particular, use the load into staging and switch mechanism when you can. And then loading in parallel does improve throughput. Now, when you go to parallelism, on column stores in particular, if you're landing into compressed row groups, you shouldn't go as parallel as you do on a heap. And the reason why is each of these compressed row groups require a memory grant. And so soon you hit memory grant contention if you go widely parallel. Start with maybe 4 and then see if you have headroom. right? And then use a compute engine to offload some of that data. So if you have some massaging of data to do, don't do it within the database. That would save you time and money sometimes, depending on what compute engine. ADF is pretty cheap from a cost perspective. For large data loads which require greater than 100 Mbps, look at Azure Data Warehouse. For truly large, DW type workloads, Azure Data Warehouse is where you need to land. The second piece we look at load and log generation. We'll look at connectivity and some of the network latency aspects of it, right? So from a connectivity architecture, we have a set of SQL DBs. When a client issues a connection with server.database.windows.net, it goes to over 1433. It first goes primarily to the gateway. Right? And the gateway then routes that connection to a backend, database. And the backend connection, is not visible to the client. So this proxy mode. The connection policy of proxy will do this. Every connection goes through gateway, and every round trip actually goes through the gateway to the database. Then you have the redirect mode or connection policy of redirect, which the initial connection goes to the gateway, and the gateway returns the actual database and location, IP, and port, right? And so all subsequent requests will go directly to that database rather than to the gateway. On the flip side, what that means is your client or your VM or your app servers has to open a range of ports for that to be possible. So that's the trade-off. So it's 11,000 to 11,999. Ports have to be opened in order for redirection to actually work. If your VM is on Azure, it shouldn't be so it depends on your policies on NSG and so on and so forth. Then the redirect queries directly go to the DB. Yeah. NSG is a security group, network security group. Yep. So let's look at what type of impact this can actually have. And so we'll look at a second demo. Sorry. I think, OK, I'm duplicated. So I'm going to look at an application here, which we don't have to worry about it. It's a low latency application. This is against business critical 80 vCore. So we're going to do a very chatty application, very low latency application. I'm going to start running. Oh, actually, let me check the policy first. So this policy is not, changing from proxy to redirect is actually only via PowerShell or CLI. It's not there in the portal today. So first thing we're going to do is actually check what that is. So I'm using PowerShell in this case, but CLI support is there too. So I get the subscription, get the context, and then I get the SQL server and specify the name and resource group. And then I'm getting the connection policy and seeing what that is set to. So we're going to check what that is. And hopefully it comes back soon. OK, so this is already set to proxy, so I'm not going to change it. So the type is currently proxy. So the first set of tests we're going to look at is with the connection policy type of proxy. Right, so I'm going to start my workload now. And let's look at a dashboard to see what latency looks like. So I'm switching my database to DemoDB. This is the 80 vCore. Log rate and all doesn't really matter right now. So you see this is climbed up already to around 53,000 batch requests a second. We'll give it another 20 seconds or so to see where it plateaus. It should plateau around 85,000 batch requests per second. So this application is generating 85,000 batch requests per second in stored procedure calls to SQL Server. So this is around. So if you see, it should plateau pretty soon. Okay, it's already plateaued here, and this is at 81,000 and something. So let's say 85,000 batch requests per second. And so we've seen the chatty application with the proxy mode. So I'm going to stop this application. And one more thing I'm going to do before I actually leave this screen. I have to make a new connection to make sure I get the new policy. So I go and make a new connection. And I'm going to include this client statistics, just to show you what the round trip latency is. Right? So I'm going to include client statistics, and this does nothing, right? So it's just initializing a variable, and I'm iterating 1,000 times for that variable. So I execute that, and it took roughly, 21, was it 21 seconds? Didn't seem like it, no. Let me zoom in one more time. Yeah, about 1 second for those 1,000 round trips with proxy. And then we'll compare it once we switch to redirect and see what that is. But this is no work, just network, pure network traffic. So I'm going to change this to redirect now. And the way I do it is with setting that resource. OK, so the connection type is now redirect. And I restart my application, the same application that I did before. And we'll give it a few seconds. Should warm up in a second. This collects every 15 seconds, so it's not totally real time. Should have actually dropped that latency. As you see, we've gone way over 100K already. Right? So this is 123K. It should plateau somewhere between 110, 125,000 batch requests a second. Right? So this is pretty good scale from that perspective. But I mean, I've not changed my app. I've not changed anything other than the redirect policy. My VM is in Azure. SQL DB is in Azure. And so that's where latency comes. So I'm going to kill this application and show you the pure round trip latency. It's when you do a variable assignment and no work, it's not going to be as impressive perhaps. So that's more than a 30% gain in that chatty application, right? So I go create a new connection and do the same thing. And, oops, again, sorry. And that was 1 second. This is almost, 700 milliseconds. So it's a significant difference for even, 1,000 round trips. So that's kind of where the gain came from, right? You don't have to go to the gateway for each round trip. So that's number 2. Yeah, sure. Why would I want to use proxy? So if your policy is such that you can only open port 1433 outbound, then you have to use proxy. There's no other option. I mean, you can't. So that's the main reason, security. That's it. But it's outbound. It's not inbound, right? So outbound ports required. Yeah. Yeah. So that's that. So from current slide. OK, the other things, the obvious ones, right? Co-locate your app in the same region. Use accelerated networking on the VM if you're using a VM connecting to SQL. That's not a label in a very small core VM, but accelerated networking I think is on by default. So if it's the older VM, you could check if that's the case. And then other best practices from a programming perspective, right? So chattiness, network latency is important on Azure, right? So if you don't need to make single round trips in chatty applications, you have a chance to redesign where you can use a TVP and batch things together, then absolutely do that. While bulk loading, don't do 1,000 or 1,000,000 inserts in a batch, rather use a SQL bulk copy API. Use set no count on if you're not banking on the done token, which tells you how many rows are affected, and you're not doing anything with that. So those are other things you look at from the app perspective. So let's move to storage. Oops, I thought the demo was first. Yep.
Could the port be different per, if I connect to one server and then I connect to another's app, let's say, could the port be different? In other words, is the port?
You have to open the range of ports outbound. Yeah. Oh.
Does that database have a port assigned to it? For that VM?
So yes. So the question was, will the SQL Server IP and port be different? I mean, it's not like I would ever recommend you. You're still connecting to the name. The initial connection goes through gateway. Then you're returned where this SQL Server and port resides. The driver takes care of all of it. It's not like you're changing your connection string any. Yeah.
I understand that. What I mean is when the SQL reports back, does it always use the same port? Just like
No.
you have an instance on
No.
once it decides on the IP port, it sticks with it?
It sticks.
You know, when you start an instance on-prem, it'll pick a port and it'll start communicating with it.
Yeah, but it's not guaranteed to stick. I mean, it's not like we want you to connect or you can connect to that, IP and port, or we would recommend that anyways. So
We have one question over there as well.
sure. That gateway is within our, SQL DB infrastructure. So it's not. So you're talking about a PaaS service or VM? So within the network, so if proxy is set, yes. If proxy is set, it'll go to the through the gateway. So there's a default setting which actually detects if the VM is on Azure, it will use redirect mode. Again, it depends on your outbound port. So if you have a VM, for example, right? You have an NSG around a VM. If you block outbound traffic and only open 1433, you can't use redirect. It has to go through the gateway. If your outbound allows all, then the default policy will actually use redirect. The question is, okay, if I have an on-prem app, do I have to open the ports? If I have a VM on Azure, do I have to open up ports? Even the VM is sitting in a VNet, right? And the VNet has an NSG. NSG can have rules to allow, but default is allow all outbound ports. So if you don't lock it down, you're fine. But if you do not allow all outbound ports, it treats it the same way as if it's on-prem, you're opening only 1433. So, I mean, the VNet rules and NSG rules for the VNet is what will determine if you can use redirect or not, right? Besides the connection policy.
And we'll take one more question.
If you have more questions, we'll take it offline.
And we'll take questions at the end, by the way, but one more, and then.
Go ahead.
So from the standpoint of just looking at security, you shouldn't really open up any outbound ports unless it's very specific ones. So what context could I really use this?
So the question was from the security aspect, I shouldn't open any outbound ports. And so how can I use this? If you cannot open those range of outbound ports, you cannot use this. It's a trade-off. That's the thing. I mean, if you can open the outbound ports, this is a tweak that will.
Yeah, and the nature of the application. But yeah, this is why this is not necessarily a default scenario either. So.
Yeah.
Okay.
Redirect. Is proxy or redirect better? If you have the opportunity to use redirect, it is lower latency than proxy would be. So storage. You have local storage on certain SKUs. So general purpose deployment model, local storage is used for TempDB only. On business critical, it's used for all the files. On hyperscale, on the other hand, it's used for TempDB and this layer called RBPX or remote buffer pool extensions cache, which is a caching layer. Yes? Local SSD storage, sure. Sure. Yeah, super fast, low latency storage. And then there's remote storage, which is also, Azure Premium SSD storage, but it's remote SSD, not local SSD, right? And for remote storage, database files for general purpose, for example, are held in remote storage. And the IOPS there are often, in all Azure Premium storage, IOPS are tied to a blob size. So you have different values. So for example, you have a size of P10. The disk size is so-and-so. I mean, the IOPS limits are the same, are 500, whereas P20 is 2300, P30 is 5000. So there are different limits, and this link has the storage limit targets and the IOPS and throughput limits for each, right? So blob size does matter, and we'll look at a demo with managed instance and how that can change things. So let's switch to the demo. So I'm going to start. This is the HammerDB normal, HammerDB workload. This is not intended to show how fast managed instance can go, because this is intended to show the storage differences, if you will. So I mean, this is going to start up. It'll plateau sometime soon, hopefully. But in the interim, we'll look at some of the properties of the file. So there are a couple new functions that expose the blob tiers of files. This is managed instance general purpose 8-core tier. And so I'm going to look at the blobs themselves. Wrong one. And I see that the blob tier here is P10. And so as we said, it's premium blob storage, and the size is whatever the size is. So this by nature inherits some properties of that storage, right? So the IOPS are 500 IOPS, and the throughput is 100 Mbps. So let's look at the dashboard for managed instance. I should have actually pulled it up. Okay, and we see about 250 batch requests per second. It's not the greatest throughput, and we'll look at waits here. Waits, the first top wait we see at 20 seconds is page IO latch sh. Page IO latch sh, as you know, if you've looked at your waits, the IO latches have to do with wait on IO, right? So the waits indicates that, okay, we are waiting on data IO, right? So we're waiting on a fetch of a page. So normally you would look at perfmon for storage. We don't have storage, so we are looking at another dashboard which pulls out virtual file stats DMV and charts out the IOPS based on virtual file stats DMV. Okay, and so looking at reads and writes. So this is the database in question. So I'm just going to highlight these. And it's the sum of IOPS of reads and writes, right? So the sum of them, as we can see, this is around 200-ish, and this is around 300-ish. So we are hitting the 500 IOPS limit for the blob, right? So if you're hitting, then storage is throttling you. If you're getting throttled, your latency goes up. So the latency is going up. The latency is at 600 odd milliseconds. In this case, and then you'll get page IO latches in your application with slowdown. So let's stop that test. So what do we do in this case? In this case, since we know the blob sizes and limits, we can actually change the file size to the next year. So just changing the size inherently will give it the next year. So I'm going to switch to that database, and I'm going to modify one of the files, which is the data file, because both of them actually had, if I had to look at the weight, I should have done that before. The next weight was write log. So it was page IO latch was one, and write log was the other. So I'm going to modify the size of both of these, and then I'm going to rerun my workload. We'll give it 30 seconds. I mean, dramatic improvement from the previous workload. And this is not stabilized, actually. If you give it a couple more minutes, it's going to go even higher. Let's look at our waits and queues now, since we have looked at it before. You see, page IO latch is still, we have to actually zoom into this period, because otherwise it's going to distort things. You know, it's dropped from whatever, 20 seconds to 13 seconds. It still is there to some extent. I can refresh this, but it's significantly less than before. And I'm pushing enough workload that actually even this tier is going to hit our IO bottleneck. But we'll see that storage IOPS have gone up. You know, we had 1.3K writes and then, you know, 1,000 reads per second, right? So blob limit does matter here. And if you've hit, you know, much higher, 184,000 transactions per minute versus, you know, around 20,000 transactions per minute because you were getting throttled. I could ratchet this up a little bit more and we could probably get to a point that CPU maxes out now, IO is not your bottleneck. Okay, let's move on to the next thing.
Yeah, if you actually flip over to 4, then I'll do a few from there.
Okay.
There we go. So Denzel was starting to talk about this with the actual wait types. For overall IO contention, you're going to look at sys.dmdb resource stats, look to see if you're hitting those IO limits. And then after that, you're looking at page IO, and then we do star because there's different types of IO latch waits to indicate any data issues or file IO issues, and then write log for any transaction log issues. And then, no, grab your question in one sec. Governor-related wait types, Denzel covered that in an earlier slide. Yeah, so question.
So about the last lab, so if you run the query that said 10, now it's going to be 20 or 30 or something. Could you run that query again?
Why don't when we do the next, so the question is, can you rerun this query again? We'll do that right on the CPU because we've got one more demo. Yeah, go ahead.
You have to switch machines otherwise. So.
Yeah, but yeah, and we'll do a bonus one too if you end up standing in line. Then we'll do that. So okay. So that's general I/O. In terms of troubleshooting, is there anything different in Azure SQL DB? So Denzel showed you a very specific scenario, but most oftentimes the troubleshooting pattern is very similar to SQL Server all up. So you're looking at, first of all, identifying what are the queries that you need to tune. You can do things like use query store to identify it, very much your friend because you can sort by I/O. Dynamic management views. I see Glenn Berry in the back. He's got some DMV scripts that you can use, again, in the cloud. The stuff that works in the box will work in the cloud as well. And then the common techniques. And a lot of this seems very basic, but there are many times, I remember one time I got pulled into an escalation, and it was the fact that they had a lot of data scientists working with actual tables that they were all just heaps. And it was just the fundamentals, the first principles of we needed to index it properly. And all of a sudden they didn't need, in this particular scenario, P15 anymore. They needed a P1, okay? So I would say not everything is a spin lock advanced issue. A lot of the times it is very much related to the fundamentals, high I/O, high CPU. Now, if you are actually needing to use the resources that are allocated, or you cannot tune it any further, or it's an application that you cannot modify, then most certainly upgrading the SLO is an option as well. But there's a reason why we put option 1 out there, because you want to make sure you do due diligence in this space. And by the way, I do also want to mention, there are a lot of databases out there that could get some tuning where you could actually save people a lot of money just by using your existing SQL Server skills to scale things down with just a little bit of tuning. And we see this on a daily basis, actually, with a lot of these escalations. A few common perf patterns also I just want to bring up again. Remember, we're picking some of the more common ones. Memory grant contention. If you looked at this runbook, you'd see a similar set of priorities in the SQL Server world as well. And this was relating to, I have a query, it gets compiled. When we compile, we have an idea of the estimated number of rows that are going to flow through that plan. And if we think that a high number of rows are going to flow through it, and we're doing things like hash operations, sort operations, then we might have a very large memory grant associated with it. And if you have multiple concurrent requests that are all asking for that large memory grant, you can start gating. And one of the symptoms of that is related to resource semaphore, and sometimes coupled with a low CPU utilization. It's very verifiable via DMVs, so sys.dm exec query memory grants. You can check it in wait stats, in query store again. But again, this is a common pattern, not dissimilar to what you might see in SQL Server world. And the optimization steps are also similar. So sometimes it's a matter of optimizing the query. Oftentimes, again, don't jump to the most complicated remediation. It might be, hey, this is missing a where clause, or this is a super wide result set of which we're only using a very small subset of columns. Just by those simple changes, you can often affect the grant size. And then there's more hands-on operations that you can perform, like hints, but again, start with the fundamentals. And again, a lot of the folks in this room know exactly how to do that in the SQL Server world. Same rules. In terms of high CPU contention, again, what did we show earlier? sys.dm db resource stats, or if you want to look at the portal, we'll talk just a little bit about that towards the end. And if if you see consuming 80% or higher for extended periods of time by CPU, then you start asking different questions, like were there recent code changes? Who are the CPU consumers? If you want to check right now, so the CPU is being burned as we speak, sys.dm exec requests. Did it happen in the past? Query store. And then a lot of the most common patterns we see in the cloud when we get cases as it might be a bad plan. How many folks are using automatic tuning and plan regression correction function? Okay, a couple of hands. It's actually been very useful for a lot of folks in both SQL Server and Azure SQL Database. And the concept is I have a compiled plan. It's running fine. For whatever reason, my plan gets ejected from cache. When the new plan comes in, it might have different runtime values that generate a new plan, or different stats that generate a new plan that for whatever reason is not as optimal as the prior one. When you enable automatic tuning with this plan regression correction, we can automatically revert to the last plan. That's essentially what happens. If you don't want that happening automatically, there's a dynamic management view where you can actually keep an eye on that type of correction. And that is a very popular feature, very simple functionality. Go back to the last good plan. A bad plan can be a big CPU consumer, high compile activity. I remember knowing of a certain large trading organization where somebody put a recompile hint into something being executed several thousand times per second, and now they're generating a fresh plan every second, 5,000 times. That can definitely burn up CPU, so you want to look for high compilation activity. And with that, we'll have, I think this is the last demo related to CPU. Switch to 3. There we go.
Okay, let's look at a high CPU demo now and see how we can resolve that. So I'm starting a scenario here which should generate high CPU. We'll double check that in a minute. So we're not going to go to the dashboard this time. We should be able to, within a few seconds, see from resource stats that CPU is high. So if CPU is high, it's already gone to 34%. Give it another few seconds. And it's up to 83%. So this is a CPU problem. I'm not going to look at weights or anything else. I'm going to try to figure out, okay, what's consuming my CPU and what can I do about it? So for CPU queries, I mean, query store is probably the easiest or best way to go about looking at it. So I have this database. I am going to go to the top resource consuming queries, right? And I have a winner, not always the case, which effectively on average, on average, I don't know if you can see that, but it takes 19 seconds or 26 seconds of CPU. Right? I look at the plan, and the plan looks pretty, hey, it's one row being returned, one index seek. It doesn't look terribly complex. It's a nested loop, not a big deal. Look at the query here, and it's a relatively simple count star from a table variable and a join, right? So in the interest of time, I've actually copied that query and populated the query, the table variable, so I can actually execute it and show you the actual plan. So I have the declared table variable, and the first part is just populating it. The second part is the actual query. This select count star is the same thing we saw before. And I execute this query. Actually, I should have done a set statistics time, sorry, so we can see the differences with and without. Should be done anytime now, hopefully. So that was the compile time. Don't care about compile time as much. Okay, first thing I go to the plan. I'm going to ignore the first plan because it's the insert into the table variable. And these lines have got a fattening pretty much. You see actual number of rows. Wow, don't know. Actual number of rows here as 300,000. But the estimated number of rows, can you guys see at the back? I'm having problems zooming for some reason. And the estimated number of rows is 1, and the actual number of rows is 300,000, right? That's because table variables, for those who have worked with table variables, we don't know the cardinality estimation at compile time, generally speaking, at least before what I'm going to show you next. And so we would estimate a row count of 1. Because we estimate a row count of 1, the optimizer thinks, well, I can do a nested loop. I'm going to row only one inner seek. Instead of that, I end up with 300, I can't even read this, 3.7 million seeks in a table. And of course, it burns a lot of CPU. Right? So CPU time was pretty high here. So before this new compatibility level, I'm not going to go into actually the workload demo. You would create a temp table potentially, and just replace that table variable with a temp table if you have the flexibility of actually changing your code, which is sometimes painful. And then the same query, instead of the 19 seconds that it took, suddenly has a better plan. We estimate correctly, and we change the plan shape. The estimation is the same as actual, right? And CPU time is significantly less. Now in Compat 150, and this is something that if you have an existing database, you will have to actually change to get this benefit. We have this deferred table variable compile feature. Joe PMs that feature, so it's an awesome feature for sure. And so I changed this compatibility level to 150. And run the same statement exactly as the original, insert and the select. And instead of my 19 seconds, I get a plan because that actually knows the right estimates because it is compiled. The table variable values or how many rows are in the table variable are used at compile time, right? So having said that, if I run this repro final, the big difference is now looking at CPU across that instance. And you will see two charts which should tell the tale of, I think so. OK. That was the previous CPU chart. And this should be a blip on the radar if we let it go for a few more minutes. I mean, that's actually finished in 4 seconds versus 2 minutes earlier, right? The whole workload.
And we have, we'll take one question, and then we'll bring it home. I think we've got 7 minutes left. Yeah.
Do you still have the rollback issue with regards to the table variable?
So the question is, do you still have the rollback issue?
The transaction is rolled back, the data in the table variable will still be there. So the next time that you go into that table variable, it might be.
I think let's talk about that one afterwards. 'Cause
The transactional context of a table variable is still different than a temp table, yes.
Yeah.
So we can talk more offline.
Anything else to show on this? Oh, let's switch back. OK. So I want to bring over a few things. So you might have seen some areas in troubleshooting techniques and you think, okay, I'm perfectly comfortable with doing that. And then you might look at this and go, well, no, I don't want to do any of this. I want to keep it as simple as possible. Or maybe you're guiding somebody else to say, hey, once you've deployed this, I'm going to help you get your best foot forward, but then it's up to you to troubleshoot this from then on out. So I just want to show you a few things to take away by the end of the session around what you can do to help yourself in the performance story at a general level. So first of all, folks who go to the overview blade for a database, you allocate a database. Overview blade is one of our most popular areas to look. We are going to front and center, and what you just see here is just a line. This is a TPCE database where I was running a workload that I knew would saturate data I/O. But we front and center show you lines across different dimensions, CPU, data, I/O. So that's one thing in the overview tab that we make clear. The other thing is if you scroll down from that overview, you'll see something around recommendations. If you are saturating DTU or vCore resources, we will tell you. And if you click on the actual tile where we say, hey, we think you're using too many resources, we'll bring you to something called Query Performance Insights. And again, you have the choice. You can use DMVs, you can go to Query Store directly, but if you want to cross-train folks to be able to troubleshoot this and they don't want to have advanced DBA skills, then you can go to Query Performance Insights. We'll show the top 5 queries by dimension of resource used. And then you can see through this chart, you can actually see the associated colors, like you see yellow here and yellow for a query ID. You can click that query ID. It actually brings you to the actual query text and the history over a period of time. And it's very easy. And again, a lot of the cases we get, had somebody just gone in and said, what's the big consumer? They would have identified the issue with the particular query, or they would have identified the query that needed troubleshooting. One other thing, and this is not talked about a lot, and I just want you to be aware of it because it's ever evolving, and a lot of it is based on actual case history that we get in, is you'll notice if you log into the portal, a few down, you'll see this diagnose and solve problems link. And one area is you'll see a health dashboard that will tell you if anything is known that's happening, either related to your database or at a systemic level. But you also have this concept of troubleshooters. So if performance is running slowly, you can scroll through that portal and basically click, and this is the example output of an actual troubleshooter where I say, hey, performance is slow. It will take maybe 5 to 7 minutes. It'll look at the current telemetry, the most recent telemetry, and it will spit out a diagnosis. So in this example, we detected high I/O for more than 90% for my TPCE database, and then here are some recommendations. So again, a very interactive, this is above and beyond Query Performance Insights, and it's something that we're always evolving depending on specific problem areas that might arise as a theme. The other thing is monitoring at scale. Let's say you have thousands and thousands or tens of thousands of databases in SQLDB. What do you do? And there are third-party options. One option I do just want to bring up before we end the session is we have something called Azure SQL Analytics, which allows you to, A, have a single pane of glass for your fleet of databases, but B, it allows you to actually emit telemetry for this offering called Intelligent Insights. I show this visualization. We can collect telemetry across your elastic database pools, across your single databases, across your managed instances, and you do have a choice. You can go to Azure SQL Analytics, or you can go to Event Hub or low-cost storage, so that is a choice. But Azure SQL Analytics is actually your curated way to look at this. So this is just a little screenshot of a few databases. It allows you to get a heat map, so I can say, okay, if something's going on, I triage and go to the proper resource, whether it's at the subscription, database, elastic pool level, managed instance level. We'll have this heat map that allows me to click through and get to the actual top performance issue. Yeah, question? So the question is this included in your subscription? This one you have to go and add. So you basically go to Marketplace, say add Azure SQL Analytics, and then you pay for the storage, and you pay per gigabyte. And there is, I think, a certain amount of buffer that you don't pay for up to a certain number of databases, but then you pay for the storage, okay? Now, one thing I just want to mention, so if you think of leaf level functionality, so I can look at counters and resource stats and query store, all of that can be collected through Azure SQL Analytics, but we have something called Intelligent Insights, and it's basically a set of advanced statistical models that can detect an array of different problem spaces. And this screenshot, by the way, is just showing, I have an insight that popped up. This is in Azure SQL Analytics. I see that there's an I/O problem. It actually spits out the query ID associated with it, gives me the query text and the time that it happened. And this is something that if you have a fleet, you have 10,000 databases, we're doing this automatically. So you would obviously run into issues of scale if you're one person and there's 10,000 databases. Now, the part I want to leave you with is these are the different patterns that this automatically actually identifies. So things like workload increase, increased wait stat types, slow clients. And even if you don't plan on using Intelligent Insights as a feature, I recommend checking out this resource link when you download the deck after this talk, because it's a great run book in general. From a DBA perspective, those of you remember that there was a white paper back in 2005 and 2008 about performance tuning, and it was about 70 pages long, and it broke into topics like TempDB and memory grants, a lot of the things we talked about today. If you look at this Books Online topic, it's going to be very much like that, a guided, operational guide of here are the different things that we can identify, and here are recommendations on how you can mitigate specific issues. Okay, so with that said, we've given you a pretty wide tour of the overall performance and availability landscape in Azure SQL Database. The big thing is we've mentioned availability is very much a part of this because you get that out of the gate. I also hope that you've seen that a lot of your SQL Server skills apply very directly to Azure SQL. And the other thing I will just leave you with is there is a lot of opportunity out there. We're in this interesting period of time. I've been working with SQL Server since 1997, and we're in this time where the hybrid DBA is becoming more and more common. And so I would just say that if you have opportunities to get hands-on with cloud-based or platform as a service, I would recommend doing so, because that is definitely where things are going. I don't think we'll always be in one place versus the other, but we've got this window of time to make that leap, and it's not that much of a leap, as you can see. All right, so with that, we'll take questions afterwards if you want to come up, but thank you very much for spending your evening with us.
Thank you.
Okay. Thank you.